So today's question is a Leetcode hard parallel courses 3. The question says that you're given an integer n, which indicates that there are n courses labeled from 1 to n. Remember that it's 1 to n, not 0 to n minus 1. You're also given a 2D integer relations, so relations j equals to previous course, comma next course. So an array that consists of two elements, a subarray of two elements, and denotes that the previous course has to be completed before next course. Previous course needs to be completed before the next course. And furthermore, you're given a zero indexed integer array. This is the first time you're getting a zero indexed array. And like array is zero index, but like it is given here that it's a 1 to n. The courses are labeled 1 to n, so we need to keep this in mind. Time with time I denotes how many months it takes to complete I plus 1th course. I plus 1th course. You must find the minimum number of months needed to complete the course. Following these rules, you may start taking a course anytime if the prerequisites are met. So we can start course anytime. Number of courses can be taken at the same time, so we can do like multiple courses. This is a good thing. It eases the job. So return the minimum number of months needed to complete all course. Okay. So like if we look at the example here, so like we given this is 1, this is 2, and we reach here to 3. So let's take a look at the example here. And relation with 1 is connected to 3 and 1 is connected 2 is connected to 3, which takes 3 months. 1 takes 3 months to complete, 2 takes 2 months to complete. So like they do these two can be done at the same time, but course number 1 will take more because it is 3 months. All right. So yeah, like we have a general idea like how these things are working behind the scenes, and what we can do is, so let's just take a look. Like this takes 2 months, 3 months, sorry, this takes 3 months, this takes 2 months. So we'll take 3 months. Currently we are at 3 months plus, then this takes 5 months. So 3 plus 5 is going to be 8. All right. So like how can we do this actually? So first we are going to create like dictionary res. First create a dictionary res and store all the connections. Like will have one will have stored like it's connected to 3, right? And 2 is going to have connected to will be connected to 3 as well. All right. And the time is going to be in a time array that's going to be distinct. uh, like distinct in the sense, I mean, like it's going to be set up, or it is given as a different array, and you can like pull the values from there, whatever is the value. This is 5. So integer, the course 1, course 2 cost 2, and course 3 cost 5. So like we can create our, like what I say, adjacency list. And after that we can do a DFS here. We can do a DFS, and we'll start from 0. Like we'll start from very this position, and like so we'll calculate from here. And for 0, like if we start from here, the very first node, instead we can start from 1 as well. But like yeah, so this we'll start with this. It is 3. Here's 3, and then we'll go ahead. We'll go to the neighbors of 1. We'll go to the neighbors of 1. The immediate neighbor is 3. Immediate neighbor is 3, and it returns like 3 plus 5, so 8 will be returned up to here, and stored, like we'll be computing max, and we'll be starting from each position, from this, and from this. And after that we move to 2. Now 2 costs 2 months, and then we'll move to the neighbor. 2 plus 7, 2 plus 5 is 7, and we'll return back to 2. So 7 is also one of the answers we got. 8 is answer we got. uh, as far as now, 8 is the greatest one. After that, 3, remember 3, we are at 5, so it's going to be 5. It's not going to be any different, it's going to be 5. So yeah, we are just going to return it back. And yeah, I guess that's pretty much it. Let me check, like, if I've done everything right here. We have to compute the dfs from 1, and in this manner we'll be able to get the maximum value, like we are getting. So the max, and also we can pre-compute the value, because if we are at 3, we can compute the maximum value that we can get from 3. So yeah, like, that's it. Now we can move on to the code part for this, and we'll just code it up fast. And yeah, so we start with the rest, that is going to be default dict list for I in relations. Yeah, it's I in relations. Res I of 0 minus 1 equal, because like we need to make it 0 indexed so that there's no confusion. And we're going to append, and we're going to append I of 1 minus 1. Alright, now we're going to make a dp array to store the values cached. Def, no, like, we can just make def as of now, and I'll break it down to you later. What am I trying to do? Def node, and we'll write pass as of now. uh, this is the computed answer value, and we'll start from each node to compute, like, what is the maximum we can get to finish. As equals to max of I comma dfs I, and in the end we're going to return answer as answer. And now the dfs part. So for this, we will store dp array, dp hash map dictionary, or we can call. And if node is present in dp, then we'll return dp of node. This makes it more efficient. If node not in dp, uh, okay, I'm sorry, like, if this is not the case, if not res node, this means that there's no connection however, and in this manner. So like, if there is no connection at all, then we can simply return whatever the time it takes. This means we are not going anywhere, and we can return whatever is time of node. If not res node, that means it's not connected anyhow. And yeah, we can return time. That's what we can do here. Again, so it means the computed value for no, or I guess in rest of node, that means the neighbors. We're going to find equal to max of ans comma dfs of neighbor and then after that we can store the value, the time, node, the current value of the node, how much the current node costs, or the course costs, store it in db of node and return db of node. I guess that do the job. Oh, you're getting the wrong answer here. Let's see. You're getting a wrong answer here. Okay, the mistake we were making was that we need to return the maximum of answer, or dfsi would be written, not like this I, which is the number of node. So like not the cost of node but the number of nodes. So yeah, I guess this should work now. So yeah, it's running. So that was it. Thank you.